today to our continuance of Chapter 4. This part of Chapter 4 we're going to be talking about isotopes and percent abundance, how to find that, and what we can tell by knowing an isotope. So let's review what an isotope is first off. An isotope is an atom of an element, and it has the same number of protons, but a different number of neutrons. A different number of neutrons. So when we're talking about three isotopes of oxygen, oxygen 16, oxygen 17, and oxygen 18, write the symbol for each, including the atomic number and the mass number. It's fairly easy to do, actually. Okay, so we're going to use a shorthand notation that we learned earlier. Okay, so we're going to need to write out three O's here. Three isotopes, 16, 17, and 18. Now all those numbers, remember, are the mass, the atomic mass of the number, of the atom. So we put that, remember we put that when we're doing our other notation, we do that up top. So 16, 17, and 18. Alright, now below goes the atomic number. So let's see, the atomic number of oxygen is right here. That is 8. So if we go back, we know that each one of these is 8. Okay, so the number of protons does not change with an isotope. It's still oxygen, so it still has 8. What changes about it is this number of neutrons here. The number of neutrons changes each time. So let's find the number of neutrons. Okay, in this one we take 16 minus 8, remember, and that gives us 8 neutrons for oxygen 16. For oxygen 17, 17 minus 8 gives us 9 neutrons. And then 18 minus 8 gives us 10 neutrons for oxygen 18. Okay, quick, easy way to find the difference in each of your isotopes. Now, they don't always go just simply by one. Sometimes they'll vary by more. All right, so now we have all of these isotopes. Now, not all isotopes occur at the same rate on Earth in the universe. Okay, so we've developed something what we call percent abundance. How abundant is each isotope in the universe? And it gives us our average atomic mass. Now, our average atomic mass is often in decimal form, so 55.66 or something like that. And if we look at a periodic table, most of our elements here, or all of the elements here, are in decimal form. Now, why are they in decimal form? Because it's taking into account the percent abundance of the different isotopes. Okay, a fluorine atom doesn't actually weigh 18.998. The average of all fluorine atoms weighs 18.998. Okay, so how do we find the percent abundance of something and the atomic mass? Well, we are given the percent abundance here. We're going to find the average atomic mass. All right, the element copper has a naturally occurring isotopes with mass numbers of 63 and 65. The relative abundance in atomic masses are 69.2% for mass with a 62.93 AMU, okay, and 30.8% for mass and 64.93 AMU. All right, so remember AMU means atomic mass unit, and 1 AMU is equal to 1/12 of a carbon atom. All right, so how do we find the average atomic mass of copper? Well, the first thing we do is we write down our AMUs. So we write down 62.93, and we're going to multiply that by the percent abundance. Now, the percent abundance, we're going to need to put that in decimal form. Okay, so I don't mean just 69.2, I mean change it, divide it by 100, so it's 0.692. Alright, and that'll give us an answer. Alright, we do the same thing for other one. We have an atomic mass of 64.93. We're going to multiply that by 30.8%, or 0.308. Okay, so we'll multiply these two across here. We've got 62.93 times 692. And that gives us 43.547. Okay, the 7's going to round up the 5. So it'll be 43.55. 43.55. Alright, now we're going to solve our next one. We've got 64.93 times 0.308, and that gives us 19.998, or in this case, we're going to have to round that up all the way to 20.00. Okay, so we've taken the mass times the percent abundance, and that gives us our weighted average. Now what we do is we add all the weighted averages together. Alright, so 43.55 plus 20 gives us 63.55 AMU for copper. Okay, let's check ourselves on the periodic table. Alright, copper's right here, 63.546, which would round to 63.55 for copper. So yeah, we did it right. That's why it's so important to show your work here. Show your work, please. Okay, because yes, I know you could go straight to the periodic table and find all this. Show me your work. I know that you actually know what you're doing. Alright, let's do one more problem and then we'll call it good for Chapter 4 practice. Alright. Calculate the atomic mass of bromine. The two isotopes of bromine have the atomic masses and relative abundance of 78.92 AMU at 50.69% and 80.92 AMU at 49.31%. So we start with our masses. 78.92 times 0.5069. Remember, we put that in decimal form, so we divide it by 100, basically move the decimal place over 2 places. We do that for our second one, 80.92 times 49.31, or 0.4931%. Okay, so run it through our calculator here. We have 78.92 times 0.5069. That equals 40.00. 5 rounds up the 4, but it does not round up the next one. So 40.00. Alright, let's do the next one. 80.92 plus 0.4931. Oops. 31 equals 81.4. Ooh, apparently we made a mistake there somewhere. Alright, so let's go 80.92 times 0.4931 equals, there we go, 39.90. 39.90. Alright, so we'd add these two together, and we're going to end up getting 79.90. Alright, so let's go back to the periodic table, check ourselves. Bromine, 79.90. So therefore, did we get it right? Yes, we did. Alright, so that's basically how we find percent abundance. Isotopes, finding number of neutrons, how they're different. If you have any questions, just let me know. Feel free to contact me. Take care.